Hello. This video is about creating AGI. But first, what is AGI? We currently have AI, artificial intelligence. AGI is artificial general intelligence, where numerous intelligence types are considered or factored in. Basically, human-like thinking. Now, that said, some may consider it to be impossible to create a nuanced AGI from the comfort of your own home or in your downtime in between semester. Or at the very least, I considered it impossible. The factors that changed my mind, well, you. Well, technically not really you, but humanity, right? So just to unpack that, wattage consumption of the human brain only goes as high as 25 watts, basically a light bulb. Random access memory, or RAM, is modeled after the human brain's ability to process a limited number of tasks at a time. Specific brain regions and subregions, I believe, can be modeled one at a time as opposed to being carried out all at once. A great way to simplify a complex project. As such, the objective would be achieve effective metacognition. An effective metacognitive simulated mechanism. And then the next objective would be the program emulates prefrontal cortical functions, not just simulates. And then other brain regions as a follow-up to the prefrontal cortex that I am working on. Or the prefrontal cortical simulation, I should say. That said, the test controls are, number one, hardware and resource constraints. For instance, wattage emulation. You know what, let me just take a second to apologize. I do have my air conditioner on the background. This is my less thematic series, my more academic series, where I am recording the work that I am doing. Anyway, now, getting back to it. Hardware and resource constraints are my first test control. And where did I leave off? Wattage emulation, which is benchmarking against the human brain's energy efficiency, the max being 25 watts, as I mentioned earlier. Treating the brain's light bulb power consumption as a performance limit. RAM modeling, using random access memory as a control for cognitive load, limiting the number of simultaneous tasks to model the human brain's processing bottlenecks. Also, quota management of the large language models being used to avoid the 429 resource exhausted errors, which drive me nuts to no end. Implementation of precise timers and 25-second delays between iterations to cool off API quotas, because God knows I am not going to pay for that shit. Number two, the second test control, logical and algorithmic controls. The decision diamond. Okay, you'll see this in a flowchart. This is, which is going to be shared in this video. This is a control for data integrity. If the alpha function output is blank, the system is hard-coded to perform a model swap, basically switching between Google and Grok. But I think I've actually ended up sticking with Grok because Google tends to run into quota errors more often. Anyway, that said, a restart, it is essentially a restart to ensure a no null data enters the memetic chain that's being created thereof. Also, the cognitive construct index usage of the alpha TTFT, which is time to first token, as a metric to set a cognitive construct index score, or CCI. This serves as a control for the purity or latency induced corruption, probably the wrong term, but I'll stick with that one for now, of the generated thought. Basically, I've discussed memetic entropy. CCI indicates memetic entropy, the purity of the ideas it propagates. Also, attention wave parameters, which is carried out in the processing mechanism function, or processing mech, uses specific mathematical bounds for the wave plugged into the theta or angle of a trig function. Basically, the metrics are frequency and phase, variable range between negative infinity and positive infinity, then timing, which is between 0 and positive infinity, amplitude between -1 and +1, or signal strength, and the formula, which is the formula for the angle of the sine wave, which I call the attention wave. It is 2 pi times frequency times timing plus the phase. Anyway, the third test control is functional isolation. In other words, neuro-emulation. This entails task sequestration. Instead of a single large language model call, I am controlling for cognitive nuance by assigning specific subfunctions of the prefrontal cortex to different isolated calls. So, for example, there are 4 main functions at work here. There's the alpha function, which simulates the prefrontal cortex's executive mechanisms or decision making. Then there's the beta function, which is attention and filtering. Then there's the gamma function, which is inhibition or regulation. In other words, the metacognitive mechanisms. And then there's the theta function, which is the domain of the theta function is social intelligence and memetic retrieval. Now, for the fourth test control, iterative controls. So trial sets. The system is limited to a specific count of trials within the async process to prevent infinite loops and ensure data is stored and converted into a structured JSON format before the log success terminator is reached. Part 1. The high-level loop and seed generation. So the research begins with the theta loop, the master process designed to trigger a chain of recursive metacognition. The system initializes by calling alpha, which serves as the primary model invocation. The immediate goal is the generation of fresh seed thoughts. At this stage, the system faces a critical decision diamond. Is the output blank? If a model fails to produce a seed, the logic dictates an immediate restart of a model swap between providers like Google and Grok, which I stated earlier. I am leaning more towards Grok due to Google and the recurring errors and my refusal to pay for the supposedly open access large language models. Anyway, moving on. Only once a valid thought is captured can the system proceed to the deeper layers of analysis. Part 2. Task isolation and neural simulation. So, to replicate complex cognitive functions, the system isolates distinct tasks to simulate the substructures of the prefrontal cortex. In other words, we break the thought down into 4 specialized functions. Alpha operates as the executive function, issues the core commands. Beta manages the attention, filtering the input data. Gamma acts as the inhibition, a regulatory mechanism that dampens natural, unrefined responses. And finally, theta functions as the social intelligence and intelligence layer. By separating these roles across different model sets, we ensure that each stage of the thought is audited and refined before it moves to the next node. Part 3. The data engine and mathematical logic. The technical backbone of this architecture relies on asynchronous processing and structured data formatting. As the system runs large language model inference or LLM inference, it tracks the alpha TTFT, again, TTFT standing for the time to first token, which is then used to set a cognitive construct index score, or CCI score. The process mechanism is defined by a mathematical wave function involving frequency, phase, and amplitude to create an attention wave. This logic ensures that the thoughts aren't just generated, but are measured for purity. All resulting data is sorted and converted into JSON formatting, allowing the system to pass a clean, structured memory from one function to the next. Part 4. Quota management and the memetic chain. Running multiple instances of high-level LLM simultaneously presents a significant hardware and API challenge. The 429 resource exhausted error, which has just driven me nuts. Anyway, to counter this, the system integrates precise timers and 25-second delays between iterations to cool off the API quotas. This finalized data is fed into the memetic chain system, where the theta function retrieves the cumulative inputs from alpha, beta, and gamma. Through a while loop that tracks iteration counts, the system recursively builds upon itself. The result is a successful log entry, a self-reproducing chain of thought that has survived the inhibition and analysis layers. Now, to unpack it all and pretty much wrap this presentation up, just to, I guess, simplify, I will just state that my workflow was relatively simple. I created a flowchart, which you've seen so far, and I basically fed it to a chatbot and had it rewrite some of my code based on what was in the flowchart. And I should say it was mostly accurate. The program functioned very well. I should state that computer science is my minor. My major is actually chemistry. I did start off as an engineering student and made the switch due to having better aptitude for the more visual aspect of chemistry. That being said, if you watched this entire video, I am grateful. This whole thing was inspired by learning and studying this notion of language being an organism. Now, if it's an organism or not, that is purely theoretical as far as I know. There is no hard evidence, nor has it been proven, but it is my belief that whether it is or isn't, it is definitely software. Okay, I'll stop there. Language is definitely software that runs in our minds. That's something I haven't proven, but something I personally believe. And if it is an organism, then can it be controlled? Can it be reprogrammed? We already see that occurring to an extent when it comes to large language models. As such, I do believe that there are some interesting things that are about to happen. For example, perhaps a linguistic event horizon, the biggest we'd seen since the birth of human civilization, with this going all the way back to the Sumerian Empire, which is probably the first linguistic event horizon in our history. That being said, if you've listened to this last minute tangent, I do appreciate it. Again, this is a small channel, but the progress and growth has been awesome and much appreciated. And please, if you like this video, feel free to hit like, comment, or subscribe, and follow for more. Thank you very much.